lectures of this design of spring, in which I have given you a complete detail of the springs and also the design of the helical spring. Today I will take it that when the springs are connected in series, then what happens? When the springs are connected in parallel, what happens? So today I will take the next lecture. So lecture number 4 of spring. Lecture number 4 of spring, right? So इसमें क्या है? When the springs are connected in series, when two springs are the three springs, you can say when it is connected in series, then what the condition arises here. So you can say, suppose this is your spring, right? So this is your spring number 1 and spring number 2. So this is connected in series. So stiffness of this is K1. This is stiffness of this K2, right? So here the W is the load applied here, right? So the deflection of the spring, delta 1 this one and delta 1 this 2. So you can say this spring is spring number 1 and this spring is spring number 2, right? So what happens when the two springs are connected in series, right? So what happens here? You can say that in this case, when the two springs are connected in series, try to understand. In this case, the total deflection of the spring, is equal to the sum of the individual deflections of the springs which are connected in series, right? So here I am taking the two springs are connected in series. Their deflection is delta 1 and the deflection of the spring number 2 is delta 2, whereas K1 is the stiffness of the spring 1 and K2 is the stiffness of the spring 2, right? So when first case है, case number 1, case number 1 क्या है? Case number 1 है when the springs are connected in series. तो जब आपके स्प्रिंग जो है सीरीज में कनेक्ट होगा, दिस इज वेरी इंपॉर्टेंट डिस्क्रिप्शन अबाउट when the springs are connected in series, so you must try to understand. So when the springs are connected in series, what happens? The total deflection, you can say total deflection of the spring. So total deflection of the spring is equal to the sum of the deflections of individual springs, sum of the deflection of individual springs which are connected in series, right? तो टोटल डिफ्लेक्शन जो आपका होगा वो किसके बराबर होगा? सम ऑफ द डिफ्लेक्शन ऑफ द इंडिविजुअल स्प्रिंग्स which are connected in series, right? So here you can say, therefore, क्या मतलब है इसका? डेल्टा इज इक्वल टू डेल्टा 1 प्लस डेल्टा 2, right? So delta is the total deflection of the spring, right? So delta is equal to delta 1 plus delta 2. And you know, spring stiffness is equal to, stiffness किसके बराबर होता है? stiffness K is equal to W upon delta, right? K is equal to W upon delta, right? Therefore, delta is equal to W upon K. So delta is equal to W upon K, right? तो delta क्या होगा? W upon K. Your load is the same one. Load is here W. This load is acting on the spring, and this load is also acting on the spring, right? So you can say, if I will say that what is delta 1, therefore delta 1 क्या होगा आपका? W आपका same रहेगा, and the stiffness is in the spring number 1. What is the stiffness? Spring number 1. This is K1, right? And therefore, and also delta 2 is equal to W upon K2, right? So the delta is equal to W upon K, because as the W load is acting on the spring. So delta 1 W upon K1 and delta 2 W upon K2. So substitute these values here. So therefore, W upon K is equal to W upon K1 plus W upon K2, right? So therefore, W upon K1 plus W upon K2. So W and W, this is cancelled. So therefore, when the springs are connected in series, so you can say 1 upon K is equal to 1 upon K1 plus 1 upon K2, right? So this is the equation when the springs are connected in series. So this is the equation when the springs are connected in series. This is very important one, where K is the total stiffness of the spring, where K is the total stiffness of the spring, and the two springs which is having the stiffness K1 and K2, which are connected in series. So you can say that the total stiffness, you can say 1 upon K, this is equal to 1 upon K1 plus 1 upon K2 when the two springs are in series. This is about your when the springs are in series. Now the next one. Now the next one is this is case 1 tha, and now I will take the second case. Second case क्या होगा इसमें? पहला केस था कि when the springs are connected in series. Second case is when the springs are connected in parallel, right? तो जब आपके स्प्रिंग्स जो है ये दोनों पैरेलल कनेक्टेड होंगे, उस केस में क्या होगा? उस केस में जो आपकी टोटल डिफ्लेक्शन ऑफ द स्प्रिंग होगी, दिस इज इक्वल टू द इंडिविजुअल डिफ्लेक्शन ऑफ द स्प्रिंग. जो दोनों स्प्रिंग और 3 स्प्रिंग आपने पैरेलल कनेक्ट किए हैं, and if you want to say what is the total deflection of the spring, you can say that the total deflection of the spring, this is equal to the individual deflections of the springs which are connected in parallel, right? So this is case number 2. Case number 2. Case number 2 क्या है? When the springs are connected, when the springs are connected in parallel. This is your, जब आपका स्प्रिंग पैरेलल में कनेक्ट होगा उस वक्त क्या होगा? सो यू कैन से ये आपका स्प्रिंग है, one spring is like this, one spring is like this, right? So this is your stiffness K1, this is your stiffness K2, ये आपका W लोड था, this is equal to जहां पे जो आपका लोड होगा this is W1 और जहां पे जो लोड होगा आपका this is W2, right? So when the springs are connected in parallel, so this is the condition here. So this is the condition here when the springs are connected in parallel, right? So just see here, इसमें आपने एक कंडीशन याद रखनी है जो मैंने अभी आपको बताया कि जब आपका स्प्रिंग्स जो है पैरेलल कनेक्ट होंगे, in that case you can say total deflection, in that case total deflection of the spring is equal to the individual deflections of the spring. जो टोटल डिफ्लेक्शन जो आपकी स्प्रिंग की होगी, जो इनकी इंडिविजुअल डिफ्लेक्शन होगी इसके बराबर होगी। कहने का मतलब है कि अगर आपकी टोटल डिफ्लेक्शन डेल्टा है और इसकी डेल्टा 1 है और इसकी डेल्टा 2 है, सो ऑल दीज आर सेम, सो डेल्टा इज इक्वल टू डेल्टा 1, दिस इज इक्वल टू डेल्टा 2, राइट? सो टोटल डिफ्लेक्शन ऑफ द स्प्रिंग इज इक्वल टू द इंडिविजुअल deflections of the individual deflection of the springs which are connected in parallel, right? Understand? So you can say therefore इसमें क्या होगा, therefore delta जो इसमें है total deflection, if the total deflection is denoted by delta, so you can say this is equal to delta 1 or this is equal to delta 2, because total deflection of the spring is equal to the individual deflection of the springs which are connected in parallel. You understand this? So इस केस में क्या करेंगे, ये आपका टोटल लोड था which is acting on the springs, ये आपका प्लेट है, इसके ऊपर टोटल लोड एक्ट कर रहा है W, राइट? सो स्प्रिंग्स आर कनेक्टेड इन पैरेलल, सो व्हाट हैपेंस, द लोड इज डिवाइडेड इन टू पार्ट्स. वन पार्ट यू कैन से दिस इज W, वन पार्ट इज एक्टिंग ऑन दिस स्प्रिंग, दिस इज नॉट K2, दिस इज K1 because I have written here 1, this is K2, right? So W1 is the load which is acting on the spring, and the W2 is the load which is acting on the spring, right? So अगर इस तरीके से if you write down the equation of the W, you can say that W is equal to W1 plus W2, right? ऐसा कर लिख सकते हैं हम. जब आपका स्प्रिंग क्या होगा, when the springs are in parallel and the load W is acting on the spring, total load W is acting on the spring, and these two springs are parallel, so you can say that the one part of the load, that is W1, is acting on the spring number 1. Suppose if this is spring number 1 and this is spring number 2, and W2 is the load which is acting on the spring number 2. So you can say that the total load W, this is equal to W1 plus W2, right? तो इसमें क्या होगा, W1 is equal to W1 plus W2, तो W हम निकालेंगे, जैसे आपको पता है स्प्रिंग स्टिफनेस किसके बराबर होता है, K is equal to W upon delta, राइट? ये अभी आपने पीछे पढ़ा है. So therefore, W is equal to K into delta. Is there any problem? Spring stiffness, this is equal to load divided by the deflection. This we have already read. So K is equal to W upon delta. So therefore W is equal to K into delta. तो इसी तरीके से जो W1 होगा, जो K1 इंटू डेल्टा लिख सकते हैं, डेल्टा 1 आएगा, W1 इज इक्वल टू K1 इंटू डेल्टा 1. लेकिन मैंने आपको बोला जो आपका डेल्टा 1 है, जो टोटल डिफ्लेक्शन ऑफ द स्प्रिंग डेल्टा है, this is equal to the individual deflection of the springs when the springs are connected in parallel, right? So you can say delta is equal to delta 1 or delta is equal to delta 2. There is no problem. So in this case, I can write W1 is equal to K1 into delta. So like this, I can write W2 is equal to K2 into delta. Is there any problem? Right? So here we have calculated the values of total W, which is acting on the spring, that is K into delta, and the two springs which are connected in parallel. So each spring is having the load W1 as well as W2. So here I have calculated W1. This is equal to stiffness is given because every spring is having its own stiffness. So stiffness is given here. K1 is the stiffness of the first spring. K2 is the stiffness of the second spring. So stiffness is given here. So you can say W1 is equal to K1 into delta and W2 is equal to K2 into delta, right? So this is the equation. This is you can say this is equation number 1. So I will substitute the values in equation number 1. तो वैल्यू को जब हम सब्स्टिट्यूट करेंगे क्या होगा? W की जगह K into delta. This is equal to K1 into delta plus K2 into delta, right? So delta यहां से कॉमन ले लीजिए आप, right? So this is K1 plus K2, or you can write it like this. Therefore K into delta, this is equal to K is common, delta, not K is common, sorry. So here delta is common. This is K1 plus K2. So delta and delta is ये चला गया यहां से. Therefore the total stiffness in this case, therefore K1 is equal to K1 plus K2. K1 plus K2. So this is the total stiffness. This is the total stiffness when the springs are connected in parallel. This is the total stiffness when the springs are connected in parallel. So these two relations are very, very important. So you must know what is the total stiffness in case of when the springs are connected in parallel. So this is equal to K is equal to K1 plus K2. And also you must know this condition that the deflection, total deflection of the spring in case when the springs are connected in parallel, this is equal to the individual deflections of the spring which are connected in parallel. So you can say total deflection इस केस में कोई चेंज नहीं होगा. जो टोटल डिफ्लेक्शन होगी वही डिफ्लेक्शन आपका जो इंडिविजुअल डिफ्लेक्शन होगा स्प्रिंग का, चाहे वो डेल्टा 1 का है, वो डेल्टा 1 is equal to delta 2 and delta 2 is equal to delta. So these are the two conditions which you have to remember when the springs are connected in parallel, right? So when the springs are connected in series, in that case, the condition is very simple one, that the total deflection of the spring, this is equal to the sum of the individual deflection of the springs which are connected in series. So in that case, your delta, that is total deflection, this is equal to delta 1 plus delta 2, and here we have got the total stiffness 1 upon K is equal to 1 upon K1 plus 1 upon K2. So these two formulas are very important one. So you must remember it, and I think you must understand that also. I have given you, I have explained each and everything what is in this you can say in this topic when the springs are connected in series or springs are connected in parallel. Now, next one I will take up concentric springs. So now the next one is your concentric springs are composite. So first you understand that what is concentric springs are composite springs. You can say that a concentric spring are composite springs. These have 2 or 3 springs, right? These are 2 and 3 springs, right? Which is having the same field length, and when it is compressed equally, right? So concentric spring और composite springs क्या है? ये 2 या 3 springs होते हैं जिनका जो आपका एक्सिस होगा वो क्या होगा? सेम होगा, सेम कंसेंट्रिक एक्सिस होगा उनका, और 2 या 3 स्प्रिंग होंगे जिनकी फ्री लेंथ जो है इक्वल होगी, और जब हम उसे कंप्रेस करेंगे तो उसकी कंप्रेशन वो कंप्रेस इक्वली होगा. सो दीज स्प्रिंग्स आर कॉल्ड द कंसेंट्रिक स्प्रिंग्स आर द कंपोजिट स्प्रिंग्स, राइट? सो व्हाई इट इज what is the function to provide such type of springs? आपको ये लगा होगा कि 2 या 2 से ज्यादा स्प्रिंग, कंसेंट्रिक स्प्रिंग या कंपोजिट स्प्रिंग हम यूज क्यों करते हैं, हमें किस लिए ये चाहिए? Why we just try to obtain this concentric spring? The reason is that first, if you want to attain the greater force, right? अगर आपको greater force चाहिए स्प्रिंग का, तो उसके लिए we apply this concentric or composite spring to obtain the greater force. We apply this one, and the second condition is किस लिए अप्लाई करेंगे? जो सेकंड कंडीशन होगा, फर्स्ट कंडीशन तो मैंने आपको बताया कि जो ग्रेटर फोर्स, और सेकंड कंडीशन क्या है कि व्हेन दीज 2 स्प्रिंग्स आर पुट इन द ऑपरेशन, राइट? व्हेन द 2 स्प्रिंग्स आर पुट इन द ऑपरेशन, व्हाट हैपेंस इन केस ऑफ एनी फेलियर ऑफ वन स्प्रिंग, राइट? योर ऑपरेशन विल नॉट बी हॉल्टेड वन, राइट? अगर कोई एक स्प्रिंग का फेलियर हो जाता है तो दूसरा स्प्रिंग जो है वो एक्ट करेगा, वो फंक्शन करता रहेगा. सो देयर विल नॉट बी एनी फेलियर ऑफ द मैकेनिज्म ऑपरेशन, राइट? सो दीज आर द 2 you can say objective. These are the 2 objectives why we use this spring. You can say why we need the composite or the concentric spring. So again I will say concentric or composite springs, these are 2 to 3 springs which are having the concentric axis, right? Which are having the same concentric axis, right? And these springs have their free length is equal, their compression is equal. You can say in compress this your free length होगा, free length is equal. Free length is equal in concentric spring सेकंड कंडीशन है कंप्रेस्ड इक्वली, तो आप कह सकते हैं जो आपकी कंप्रेशन होगा एक स्प्रिंग का, डेल्टा वन इज द कंप्रेशन ऑफ वन स्प्रिंग, सो यू कैन से दैट इज इक्वल टू डेल्टा टू, जो कंप्रेशन ऑफ द दूसरा स्प्रिंग होगा दिस इज इक्वल, दिस इज द कंडीशन, राइट। नेक्स्ट कंडीशन इसमें क्या आएगी, अगर आपकी इसकी फ्री लेंथ इक्वल है और कंप्रेशन इक्वल है, तो थर्ड कंडीशन इसमें आएगी जो आपकी सॉलिड लेंथ है, सॉलिड लेंथ जो आपकी क्या होती है N1D1, दिस इज इक्वल टू N2D2, जो सॉलिड लेंथ होगी आपकी इस केस में दैट इज आल्सो इक्वल, एंड इफ वी आर using the same material, you can say if we are using the same material, then the stress, maximum stress on each concentric spring that is equal, right? जो maximum stress होगी spring में if we are using the same material, so you can say that in case of same materials, the stress क्या होगी, the stress is same, the stress is same for the concentric spring, right? Or you can say tau 1 this is equal to tau 2. अगर हम सेम मटेरियल यूज करते हैं तो आपका जो tau 1 है दिस इज इक्वल टू tau 2. सो दीज आर फ्यू कंडीशंस हियर नाउ, राइट. अब ये कहां पे यूज होता है, वेयर इट इज यूज्ड, राइट. सो यू कैन से इट इज यूज्ड इनटू स्प्रिंग बॉल इन द एयरक्राफ्ट का जो स्प्रिंग बॉल है वहां पे इसको इस्तेमाल करते हैं. रेल रोड सस्पेंशन में इसको इस्तेमाल किया जाता है. हैवी ड्यूटी डीजल इंजन में इसको इस्तेमाल किया जाता है, राइट. सो इस टाइप का जो कंसेंट्रिक स्प्रिंग्स है ये जहां पे यूज किए जाते हैं. यू अंडरस्टैंड दैट. सो अगर हमें, जैसे मैंने आपको बताया, इन ऑर्डर टू डिजाइन द कंसेंट्रिक स्प्रिंग ऑफ द सेम मटेरियल, अगर आपको कंसेंट्रिक स्प्रिंग अपने सेम मटेरियल का डिजाइन करना है तो उसके लिए क्या होगा, जो मैंने आपको कंडीशन दी थी कि सेम मटेरियल के इसमें जो पहला क्या होगा, स्ट्रेस आपका सेम होगा, राइट. अगर स्ट्रेस आपका सेम होगा एंड इन ऑर्डर टू गेट द सेम स्ट्रेस फैक्टर, इन ऑर्डर टू गेट द सेम स्ट्रेस फैक्टर दैट इज K1 इज इक्वल टू K2. अगर आपको सेम स्ट्रेस फैक्टर आपको इक्वल चाहिए तो उसके लिए आपका जो स्प्रिंग इंडेक्स नंबर होगा C, दैट इज आल्सो इक्वल टू ईच अदर, राइट. सो यू कैन से इन दिस केस, इन केस ऑफ डिजाइन ऑफ concentric springs of same material, तो पहला क्या है, स्ट्रेस फैक्टर इसका सेम होगा, राइट. दैट tau 1 this is equal to tau 2, and in order to get the same stress factor, or you can say in order to get the same stress factor, that is K1 is equal to K2, what we require here, इसके लिए हमें क्या होगा, जो स्प्रिंग इंडेक्स होगा इसका, द स्प्रिंग इंडेक्स, यू कैन से द स्प्रिंग इंडेक्स of both springs, that is the outer spring as well as the inner spring, because the axis is concentric to each other. One spring is outer spring and the other spring is inner spring because it is in the helical form. It is in the helical form, right? So one helical form is like this, right? It is having the same concentric axis, and the second spring is having the same axis. What it is the inner spring. So you can say that the mean diameter in both the cases is different. Mean diameter, if you can say that the D1 is the mean diameter of the outer spring, then D2 is the mean diameter of the inner spring. So in case of design of this, we have to calculate every, you can say every dimensions, means you have to calculate the mean diameter of the outer spring, you have to calculate the mean diameter of the inner spring, you have to calculate the diameter of the outer wire, spring wire, diameter of the inner spring wire, number of turns of the outer spring, number of turns of the outer spring wire, number of turns or number of the coils of the inner spring wire. So these are the design factors that we will take up after one. First, I will just simply explain this thing that if you want to design the spring of the same material, so what we can say in case of the spring which is having the same material, that if you want to design the concentric spring, then tau 1 this is equal to tau 2. In case of same material, जो आपका stress होगा, shear stress इनमें होगा, this is same होगा. First condition is, and in order to get the same stress factor, in this case K1 is equal to K2, the spring index of both the spring is same. Both the spring are same. तो ये आपको समझ आ गया. So these are the conditions which we require during the design of the concentric spring or the composite spring, right? मैं फिर इसको explain करूंगा. Concentric spring or the composite springs are those springs, you can say these are the two springs, more than two springs or two springs which are having the same concentric axis, and one spring is a outer spring, behave as an outer spring, and the other spring will behave as an inner spring, right? So in this case, what is happened that there are certain conditions which I am explaining you, that the free length is equal in concentric spring. They are compressed equally. If they are compressed equally, then delta 1 is equal to delta 2. Solid length of the concentric spring or the composite spring, that is also equal. That is N1 D1, this is equal to N2 D2. And in case of same material, if we are using the same material, then you must understand this, that the stress is same. In that case, stress is same when you are using the same material for the concentric spring. The stress is same, that is tau 1 is equal to tau, right? तो अगर आपको ये अपने डिजाइन करना है concentric spring of the spring material, तो first condition tau 1 is equal to tau 2 को हम लेंगे, और in order to get the same stress factor K1 is equal to K2, हमें क्या चाहिए? जो आपका spring index होगा दोनों का, ये आपका बराबर होना चाहिए. That is C1, this is equal to C2, this is equal to C, right? ये आपको समझ आया? So now let us start the design of this, that how we will do it. Just देखिए यहां से इसकी हम इक्वेशन ड्राइव करेंगे. So I think this is up to this is clear to you. Now I will rub it and go for the calculations. Yeah, how I will do it. Just see. Consider the concentric spring. ठीक है? ठीक फिट कीजिए इसमें लेट W1 let W is the axial load acting on the spring. W क्या है? Axial load acting on the spring, concentric spring लिख लीजिए. Axial load acting on the concentric spring, right? So therefore W1 axial load shared by the outer spring, or you can say axial load acting on the outer spring, right? तो जो W तो टोटल लोड था, तो कंसेंट्रिक स्प्रिंग के ऊपर एक्ट कर रहा था, तो W1 आपका क्या होगा? दिस इज द एक्सियल लोड शेयर्ड बाय द आउटर स्प्रिंग. सो यू कैन से लोड शेयर्ड by the outer spring, right? W2 load shared by the inner spring. D1 mean diameter of the outer spring. D1 mean diameter of the outer spring. D2, so mean diameter of the inner spring, right? इसी तरीके से आप D1 ले लीजिए. D1 spring wire diameter of outer spring, ठीक है? तो D2 क्या होगा? ये आपका इनर स्प्रिंग का होगा, राइट? इसी तरीके से Δ1 deflection of outer spring, Δ2 deflection of the inner spring, and Τ1 shear stress on the outer spring. Τ2 shear stress on the inner spring, right? इसी तरीके से N1 number of turns of the coil in the outer spring, and N2 number of turns of the coil, the number of turns of coil in outer spring or n2 number of turn in the coil in inner spring. So these are the parameters. These are the parameters which are given here. So these are the parameters which are given here. Now we have to design the concentric or the composite springs, right, of the same material. Just see it, but derivation of this. So I think you must write down these things. Concentric spring. That W is the actual load acting on the concentric. At W you have, that is the total load which is acting on the spring, right? W is the total load which is acting on the concentric spring. So definitely जब W load उसका concentric spring के ऊपर act करेगा. So there are two springs. That one is the outer spring and the second one is the inner spring. So definitely that load has been shared by the two springs. So you can say that the W1 is the load shared by the outer spring. W2 is the load shared by the inner spring. So D1 is the mean diameter of the outer spring. तो जो आपका हेलिकल फॉर्म में स्प्रिंग होगा, तो आउटर स्प्रिंग का जो डायमीटर है, दैट इज द डायमीटर, मीन डायमीटर, उसका डायमीटर D1 से डोनेट करते हैं. और जो आपका इनर स्प्रिंग होगा, उसका डायमीटर, मीन डायमीटर इज सेपरेट, दैट इज डिफरेंट, एंड दैट इज D2 इज द मीन डायमीटर. इसी तरीके से D1 और D2 स्प्रिंग वायर, जो आपने वायर इसमें इस्तेमाल किया है आउटर स्प्रिंग के लिए, आपने डायमीटर ऑफ द वायर दैट इज अ डिफरेंट वन. जो इनर स्प्रिंग है उसके लिए डिफरेंट वन है जो डायमीटर ऑफ द वायर होगा. सो D1 इज द स्प्रिंग वायर डायमीटर ऑफ द आउटर स्प्रिंग, D2 इज द स्प्रिंग वायर डायमीटर ऑफ द इनर स्प्रिंग. सो दीज आर द पैरामीटर्स which we will first write down, and now we will start. It's the deriving the equation or designing the concentric spring, that how we will do it. Just see here, right? Now I will first rub it because I need the space to write down. So ये आप नोट कर लीजिए और ये अभी मैं इसको रब कर दूंगा. तो just see here. तो केस फर्स्ट लीजिए आप. केस फर्स्ट क्या है? केस फर्स्ट है assuming the concentric spring is made of same materials. तो मैंने अभी आपको बताया कि अगर आपका कंसेंट्रिक स्प्रिंग इज मेड ऑफ सेम मटेरियल का होगा, मटेरियल इसमें सेम होगा, तो इसमें फर्स्ट कंडीशन जो मैंने अभी आपको लिख के बताई थी, सो इन दैट केस योर स्ट्रेस इज सेम, राइट? सो यू कैन से स्ट्रेस is same in concentric spring. तो स्ट्रेस जो होगी कंसेंट्रिक स्प्रिंग में आपकी सेम होगी. तो कंसेंट्रिक स्प्रिंग जैसे मैंने आपको बताया है, इसका एक आउटर स्प्रिंग होगा, एक आपका इनर स्प्रिंग होगा, और जो इसका एक्सिस होगा दैट इज कंसेंट्रिक टू ईच अदर, राइट? सो इट मीन्स कि इन दोनों के बीच में जो स्ट्रेस होगी वो क्या होगी? सेम होगी. सो इसका मतलब ये है कि व्हेन द स्ट्रेस इज सेम, सो दिस इज द कंडीशन. सो व्हेन द स्ट्रेस इज सेम, इट मीन्स दैट τ1 दिस इज इक्वल टू τ2, राइट? जहां तक तो आपको क्लियर है, क्योंकि ये मैंने आपको पीछे बताया. अब मुझे बताइए τ1 किसके बराबर होता है? ये आपने पीछे पढ़ा था. τ1 इज इक्वल टू, अगर τ1 लिखिए हम K1 8 W1 D1 pi d1 cube, right? This is for one spring, where K1 is the stiffness factor of the spring number 1, or you can say outer spring. K1 is the stiffness factor for the outer spring. W1 is the load shared by the outer spring. D1 is the mean diameter of the outer spring, and pi, right? Pi is the constant factor, and D1 is the spring wire diameter of the outer spring. So this is the shear stress का जब पीछे जो मैंने आपको हेलिकल का डिजाइन किया था स्प्रिंग का, तो वहां पे shear stress का ये मैंने डिराइव करके बताया था आपको फार्मूला, that is shear stress tau is equal to K8WD divided by pi d cube. I think this is the formula which we have tried. So here I am writing it. So you can say this is equal to, ये tau 2 है तो यहाँ पे आएगा K2 8W2 d2 pi d2 cube, right? So देखिए 8 और 8 ये कैंसिल हो गया, राइट? पाई और पाई ये कैंसिल हो गया, राइट? अब देखिए मैंने कहा था कि इफ वी आर डिजाइनिंग द कंसेंट्रिक स्प्रिंग ऑफ द सेम मटेरियल, in that case your stress is same, and in that case we will take your spring factor, this factor K1, like this factor, shear stress factor, this is K1, this is equal to K2, right? So this is K1 is equal to K2 when the stress is same in the concentric spring. तो K1 आपका क्या होगा? K1 जो था, this is equal to K1, this is equal to K2. In order to design the spring of the same material, I have given you the condition that in that case K1 is equal to K2, and if this is K1 is equal to K2, it means in that case C1 this is also equal to C2, right? Spring index number भी दोनों का बराबर होना चाहिए, तो ये जो conditions मैं साइड पे लिख देता हूँ, right? K1 is equal to K2 and C1 is equal to C2. I think you understood up to that point. तो अगर K1 K2 के बराबर है तो मैं इसको भी काट सकता हूँ, राइट? तो अब ये आपकी इक्वेशन क्या बनी? सो नो योर इक्वेशन इज W1 D1 D1 cube, this is equal to W2 D2 and D2 cube, right? So this is, you can say, this is equation number 1. This is your equation number 1, right? Now, write on the second case. Case number second क्या आएगा? Case number second. If both the springs are effective throughout its working, अगर इसकी वर्किंग के हिसाब से देखें तो ड्यूरिंग वर्किंग क्या होगा? इनका फ्री लेंथ जो है, केस सेकंड में क्या है? फ्री लेंथ, मैंने बताया था आपको, फ्री लेंथ इज सेम, ठीक है, फर्स्ट कंडीशन, एंड दैट इज कंप्रेस्ड इक्वली. दैट इज कंप्रेस्ड इक्वली मींस इट्स डिफ्लेक्शन इज सेम, राइट? सो यू कैन से सेकंड, इसमें आएगा deflection is same, which is only the second condition है, right? So देखिए, deflection is same, so you can say delta 1 is equal to delta 2, right? When the deflection is same, delta 1 this is equal to delta 2, and what is your delta 1? What is your delta 1? Delta 1 this is equal to 8 W1 dq g d4, राइट, यही फार्मूला है। So delta 1 is equal to आप ऐसे लिखें 8 W1 D1Q into N G D1 raised to power 4, right? So this is equal to 8 W2 D2 Q into N G D24, right? So this is deflection is same. So deflection, this is the deflection of the one spring and this is the deflection of the second spring. So where W1 that I have explained you, what is D1 that is also I have explained you, and this is not, and this is N1 and N2 because this is N1 and this is N2, right? N1 is the number of turns or number of the turns for the first spring and this is N2 the number of turns for the second spring, right? So ये 8 और 8 आपका कैंसिल हो जाएगा, G और G आपका कैंसिल हो जाएगा, right? Look here, so इसमें मैं इस इक्वेशन को अगर ऐसे लिखूं W1 D1Q N1 into D1 raised to 5, कोई फर्क पड़ा? मैंने D1 से इसको मल्टीप्लाई और डिवाइड कर लिया। I have multiplied this equation by D1, multiplied and divided this equation by D1. So this is D1 into D1, right? In the same way, I will write on here W2 D2Q N2 into D2 and this is equal to D2 raised to power 5. Is there any problem? No problem. No, look here. This is N1 D1 is what? And N2 D2 is what? This is the solid length. This is the solid length of the spring. And during this, when I just started its design, I said its free length is same. Assume its solid length is also same, right? So free length same है तो solid length भी इसका same होगा. इसका मतलब है N1 D1 this is equal to N2 D2, right? So ये दोनों आपस में बराबर है. So therefore you can say therefore N1 D1 is equal to N2 D2. Is there any problem? No problem. तो ये सेम है तो ये आपके कट जाएंगे, राइट? तो सेकंड इक्वेशन आपको क्या मिला इसका? What is the second equation? Therefore W1 D1Q raised to our D1 raised to our 5. This is equal to W2 D2Q D2 raised to power 5, right? So you can say, suppose this is your, you can say this is your equation number 7, right? Now I will just rub it. मैं इसको ऊपर ले लेता हूं। सो इक्वेशन फर्स्ट थी आपकी, इक्वेशन फर्स्ट थी, मैं लिख देता हूं इसको W1 D1 अपॉन D1Q, दिस इज इक्वल टू W2 D2 into D2Q. This is your, you can say, equation first, right? Now I will wrap it. Now this is the equation W1 D1Q D1 raised to power 5. This is equal to W2 D2 Q plus D2 raised to power 5. So this is equation. Now dividing equation second by first. Next step is divide equation second y first. ठीक है, तो इक्वेशन को डिवाइड करो, देखिए क्या आएगा इसका, दिस इज W1 D1Q अपॉन D1 रेज़ टू पावर 5 इनटू D1Q upon W1 into D1. Right? So this is equal to W2 D2Q upon D2 raised to power 5 into D2Q upon W2 D2. Is there any problem? I think it's okay. So W1 and W1 यहाँ पे कट गया ये आपका. So D1 से ये कटा दो, ये बन गया आपका स्क्वायर. So D1Q कटा दो, ये बन गया आपका स्क्वायर. ठीक है, तो लेफ्ट हैंड साइड में आ गया आपका D1 स्क्वायर अपॉन D1 स्क्वायर. दिस इज इक्वल टू व्हाट? सेम जहां पे भी होगा, W2 कट गया, D2 से ये काटा हमने D2 से, ये स्क्वायर बन गया, ये D2 पूरा काट दिया, ये हो गया, ये स्क्वायर हो गया, राइट? So this is equal to D2 square upon D2 square, right? So you can say this is your equation number 4, right? R इसको आप ऐसे भी लिख सकते हैं, R D1 upon D1, this is equal to D2 upon D2, and this is equal to C1. This is equal to C2, because your C1, what is your C1? C1 is equal to D1 upon D1, and C2 this is equal to D2 upon D2, right? समझाया ये स्प्रिंग इंडेक्स वर्क. C1 is equal to D1 upon D1, C2 is equal to. तो यही चीज तो हमें प्रूव करनी थी इसमें कि अगर इफ वी आर यूजिंग द सेम मटेरियल एंड वी आर डिजाइनिंग दिस, इन दिस केस you have the spring index number that should be same. Spring index number that should be same, and this we have calculated here. D1 upon D1, this is equal to D2 upon D2. That is the case when we are using the concentric spring of the same material. So in that case, we have taken shear stress factor K1 is equal to K2. We have taken the solid length N1 D1, this is equal to N2 T2, this is also equal, and now we have calculated this C1, this is equal to C2, that is spring index number. C1, this is D1 upon D1, this is equal to D2 upon D2, right? So ये आपका आ गया इसमें. Now the next one we will do. So this is equal to first and fourth. Now again further I will take this. अगर मैं दोनों इक्वेशन को लूं, this is your first equation and this is your fourth equation. अब मैं लिखता हूं यहां पे from equation first and fourth. From equation first and फोर. देखिए फर्स्ट इक्वेशन क्या थी, लिखिए यहां पे फर्स्ट इक्वेशन आई विल राइट डाउन. दिस इज इक्वल टू W1 इंटू D1 क्यूब, दिस इज इक्वल टू W2 इंटू D2 क्यूब, राइट. तो मैं इसको इस तरीके से भी लिख सकता हूं, और यू कैन से W1 इंटू D1. मैं अगर इसको ऐसे लिखूं D1 स्क्वायर इंटू D1, कोई फर्क पड़ा? D1 स्क्वायर इंटू D1, इज देयर एनी प्रॉब्लम? ठीक है. इसी तरीके से दिस इज इक्वल टू W2. अब इधर आ जाओ D2, दिस इज इक्वल टू D2 स्क्वायर इंटू D2. अब ये सोच रहे होंगे व्हाई आई हैव डिवाइडेड दिस D1 क्यूब इंटू D1 स्क्वायर इंटू D1 और D2 क्यूब इंटू D2 स्क्वायर इंटू D2. व्हाई आई डिड लाइक दिस? बिकॉज इफ यू विल सी योर इक्वेशन नंबर 4, this is D1 square upon small D1 square. This is equal to D2 square upon small D2 square, or D1 upon small D1, this is equal to D2 upon small D2. So this is your spring index number and this is same. And if you will see this, which I have broken the equation like this, so D1 upon D1 means what? D2 upon D2 is what? That is C1 and C2, right? So according to the equation number 4, D1 upon D1 is equal to D2. जे क्या बराबर है आपस में, तो ये क्या होगा? कैंसिल हो जाएगा. ये पॉइंट समझा? Now this will be cancelled because both are same. According to the equation number 4, which we have designed here, that in case of this concentric spring, ये जो आपका स्प्रिंग इंडेक्स नंबर होगा दैट इज सेम. तो जे और जे कैंसिल हो जाएगा, तो आपके पास क्या इक्वेशन बचेगा? यहां पे आपके पास इक्वेशन बचेगा W1 अपॉन D1 स्क्वायर इज इक्वल टू W2 अपॉन D2 स्क्वायर. Or you can say, this is a very important formula here, or W1 upon W2, this is equal to D1 square upon D2 square. तो ये फार्मूला बहुत इंपॉर्टेंट है. ये रेशियो आपका वेट यहां से आप निकाल सकते हैं, और अगर आपको एक वेट दिया है तो यू कैन कैलकुलेट द सेकंड वेट, राइट? So W1 upon W2, this is equal to D1 square upon D2 square. So you can say you will write down this equation as equation number 5, right? Now next one, radial clearance between radial clearance of concentric spring between here between the two concentric spring, right? तो देखिए मैंने जैसे आपको बताया था concentric springs क्या है. There are two springs. One is called the outer spring and the second one is called the inner spring, right? So outer spring is having its own mean diameter. That mean diameter is equal to d1. This is denoted by d1. And the inner spring, this is also having its own diameter, mean diameter. This is equal to d2. तो radial clearance निकालना, तो radial means that is not the diameter clearance, means radial clearance. तो इसके लिए क्या करेंगे हम? d1 minus d2 divided by 2. ये हो गया जो इसका आउटर एज था d1 minus d2 by 2 माइनस, अब जो स्प्रिंग वायर है इसका स्मॉल d1 is the diameter of the spring wire of the external spring, and the small d2 is the spring wire diameter of the internal spring, inner spring. So you can say d1 plus d2, right? ये आपका रेडियल क्लियरेंस बनेगा d1 minus d2 divided by 2 minus d1 plus d2 divided by 2, right? But usually जो रेडियल क्लियरेंस होता है इसका, बट यूजुअली जो रेडियल क्लियरेंस है दैट इज डिनोटेड बाय, बट लिख लीजिए आप, बट यूजुअली द रेडियल क्लियरेंस इज d1 minus d2 divided by 2, right? So you can say this equation you can equate with this equation. You understand this point? So radial clearance between the two springs, this I calculated, d1 minus d2 divided by 2 minus d1 plus d2 divided by 2, and this is equal to what? This is equal to d1 minus d2 divided by 2, right? Is there any problem? Or you can say, or so d1 minus d2 divided by 2, this is equal to, ये तो दे देंगे इसको, ये हो गया d1 by 2 minus d2 by 2 माइनस ये तो जाएगा प्लस d1 by 2 this is equal to d1 by 2 minus d2 by 2 So minus plus d1 by 2 minus d2 by 2, right? Yes. So J और J आपका कैंसिल हो जाएगा, राइट? तो J आपका आएगा or you can say d1 by 2 you can say this is d1 minus d2 by 2. This is equal to 2 d1 by 2, right? 2 और 2 ये कैंसिल हो गया इसमें. So d1 by 2. So इसको हम ऐसे भी लिख सकते हैं, d1 by 2 है तो आपको पता है d1 is equal to c d1 and d2 is equal to c d2. Is there any problem? We can write it like this. So इनकी जगह हम ऐसे लिख लेंगे d1 by 2, ये आपका आ जाएगा c d1 by 2 minus c d2 by 2. This is equal to d1 or c d1 by 2 minus d1. This is equal to c d2 by 2 और d1 is क्या बना गया c by 2 minus 1 is equal to c d2 by 2 or c minus 2 by 2. This is equal to c d2. So therefore ये क्या आएगा d1 upon d2. This is equal to c upon c minus 2. ठीक है? So this is your equation. So the ratio of the diameter, ratio of the spring diameter, spring wire diameter, ratio of the spring diameter, this is equal to c upon c minus 2. This is very, very important formula to calculate the diameter of the spring wire. So this is all about, you can say, concentric spring. This is all about your concentric spring, and this is the derivation. And regarding this, you can solve few problems also. I will take up 1 or 2 problems regarding to this so that you can well understand this chapter, well understand this topic, what is the concentric spring. I hope you understood it well. This is I have given you the clear cut equations, how you will drive it, and this is I have given to you. I think it's all right to you. Just now see next one.